Hello my dear students, I hope you're all doing well. My name is Benatang Paton and I welcome you to this channel, the classroom, where we learn together. So continuing with the lecture, continuing further with the discussion on the topic on the chapter electricity. Today this is the third video, and then today we'll be talking about a very important topic which is called potential difference. Okay, this is a very important topic. So remember, this is a very important topic. You have to understand this. So it's a very important topic, and so I will try my very best to help you understand. Okay, so what I want you to do is, as usual, okay, and I also thank you for cooperating, and I am much grateful and thankful to you for maintaining good notes. Okay, whatever is being discussed in the classroom, it is going to be beneficial for you. So today also, okay, take out your notebook, grab a pen or a pencil, and okay, take down the notes. All right, so with that, okay, you will understand better. Okay, the coordination between your eye and your hands, okay, this is very effective. So this is one useful practice which you should implement in your daily routine. Okay, so always practice writing also. Whatever you have memorized or whatever you have known, okay, practice writing. Answer writing practice is very important. So always try to write. Okay, writing helps you retain memory much longer. Okay, studies have shown that when you write, okay, you are able to recollect better and retain the memory longer than just listening. Okay, so with this note, let's jump into the topic. So today's topic is going to be potential difference. Now be honest with me, okay, and I'm gonna ask you this question. Do you know what potential difference is, my dear students? Okay, who knows potential difference? Raise your hand. Yes, so some of you know, some of you don't know. So see, potential difference, okay, if I were to give you out the definition of potential difference is the amount of work done in moving a unit charge from one point to another. Okay, did you understand anything? Let me repeat. Potential difference is the amount of work done in moving a unit charge from one point to another. Did you understand anything? I have repeated the definition twice. No. Okay, so that means I cannot start with this topic. Okay, so that means I cannot, because you are not familiar with what potential difference is. So this is a very fancy word for you then. So being a very fancy word, okay, let's just erase this one. So forget about potential difference for now. Okay, instead of potential difference, let me use some terms which you are able to remember. So what if I write push? What if I write push? What if I write push? Do you know what is push? Yes, of course you know what is push. Push, na? Pushing an object. Okay, push. Okay. Then what if I write force? Do you know what is force? Of course, na? Sir, what are you asking? We know these things, okay? We have studied in class 9. Yes, very true. You have studied in class 9. What is force? Force is actually a push or a pull on an object, isn't it? So basic class 9 science, okay? You're smart, so you know, okay? Then energy. Yes, sir, we know energy. Okay, energy is the ability to do work. Yes. So now see, push is force. Okay, and then in order to push in order to execute push, okay, which is a force, is it required for the body to have energy? Yes or no? Yes, of course, the body should have energy to na. Okay, so the body should have energy. Yes or no? The body should have energy. So if a body has energy, the body can execute a push, which is a force. Yes or no? So are they related or not? Yes. Since they are related, shall we put them in a box? Yes. Let's put them in a box, because they are almost the same thing. Okay. Push, force, energy, they are all interrelated. So let's put them in a box. All right. So just keep them like that. Okay, just keep them like that. Later on we will come to potential difference. Okay, so we'll start with something which you know. Since you know these things, let me start from here and gradually I'll come to the topic. Okay, now further going into the discussion. Now remember, my dear students, okay, today's topic is potential difference. So in potential difference, okay, what are we going to discuss? Let's start the discussion now. So let us start with something which you know. In the previous video I have told you that charge is carried by, okay, charge is carried by electrons. Okay, when electrons move, it is called charge. So charge is carried by moving electrons, is it not? We already know this. Okay, so when the electrons move, okay, the movement of electrons itself, okay, is called charge. So charge is carried by moving electrons. All right, now the question is, see here, the charge is moving, the charge is moving. Now this is something very big. Okay, how is the charge moving? Is it not? How is the charge moving? The charge cannot move by itself. Remember, we are talking about electrons moving. Electrons are negative charge carriers. So this electron is moving. So how is the electron moving? Okay, movement is happening. This electron is moving. This electron is moving. Okay, this electron is moving. So shouldn't there be, okay, a force or an energy which is acting on this electron, which is making the electron move? Yes or no? Yes. So see, charge is carried by moving electrons. We know that. Okay, charge is moving by charge is carried by moving electrons. When electrons move, it is called charge. Okay, it is called charge. But the big question here is, how is the charge moving? How is charge moving? Okay, how is charge moving? So this is the big question, isn't it? How is charge moving? We want to know how charge is moving. Okay, movement means moving from one point to another point. Okay, let's say from point A to point B. So the charge is here, and now the charge is going here. Okay, so the electron was here, and now the electron is going here. Isn't that what is movement? Yes, movement is this. If I stand here, okay, and just let time go, am I moving? No, this is not called moving. Movement will be when this is my initial position, and then I move, and then I come back here, and I'm here now. So this is my final position. So I have that was my previous position A, and now this is my new position B. So have I moved? Yes, I have done movement. Okay, so moving, electrons are moving from one point to another point. Now, in order to move, I'm using energy generated by my body. So I rely on my body. The food which I ate is providing me the energy required for me to move. Okay, so I'm burning energy and I'm using energy to move. But what about our electron? This electron is moving. Who is pushing this electron? From where is this electron getting the energy to move from one point to another point? Don't you want to know? You want to know, isn't it? And that's why I'm here. Okay, I'll teach you why the electron is moving, and that is our lesson today. Okay, that is our lesson, a very, very, very important lesson. Okay, so let's understand in detail, okay, how the electron is actually moving. So let's draw the figure here, because I'll be needing this figure till the end. So I don't want to erase this, so I'll just start here. So this is one point, and say this is the other point. Okay, so this is say point A. Okay, point A, and this is point B. Now where are the electrons present, my dear students? Where are the electrons present? Remember, tell me, electrons, okay, where are they present? Who has free electrons? Who has free mobile electrons? Conductors, insulators, semiconductors. Do you remember anything? Flashback coming to your mind? Yes, it is the, which one? Who has the free electrons? Conductors, is it not? It is the conductors. So examples of conductor, what did I write? Tell me, what example of conductor did I write? Examples of conductor, they were copper and aluminum. Okay, so see, they are metals. Okay, so let's take a metal. Okay, let's take a metal, because we need free electrons. Our discussion is about free electrons. We need electrons. Okay, we need electrons. So where will the electron be? Electrons will be present in metals. Okay, so let's take a metal. Okay, we'll take a copper metal. So let's take a metal. So let's take a copper wire, and let us make it like this. So what is this? This is copper metal. Okay, this is copper metal, which is a wire in this case. Okay, in our example, this is a wire. Okay, this is a wire. Now, throughout the length of the wire, there are free electrons, because the wire is made of metal. Metal carries free electron. So throughout the wire, we have got free electrons. Free electron here, free electron here, free electron here, free electron here, free electrons here, free electrons here, free electrons here. Throughout the length of the wire, okay, throughout the length of the wire, there are crores and crores of free electrons throughout the metal wire. Remember this, okay? There are plenty, okay? There are plenty free electrons, okay? There are crores and crores of free electrons in this copper wire itself, okay? So there are free electrons here. Now, what do? We want the electrons to move. We want these electrons to move, okay? We want the electrons to move. Where do you want me to move the electron? From B to A or from A to B? Anywhere, okay? I can make it move from A to B. I can make it move from B to A. You can also make it move from A to B. You can also make it move from B to A. Anywhere, okay? You can. There is no problem about the direction. But, okay, we'll make the electron move from this end to this end. Okay, so the electrons will move from this end to this end. So now the question is, how do I make this electron, which is here, move all the way to this part? Okay, how do I make the electron move? So remember the example which I told you. I'm here. If I want to go there, I need to move. So in order to move, I need energy. Okay, I need a push. I need energy. Okay, so I need to move by myself. So my body has that energy. I ate food. Okay, and the food that I ate has been broken down, and it has given me energy. So I have energy, so I can move. Okay, I can move by myself. I'm using my own internal energy. Okay, which my body, which my cells are giving me. But unfortunately here though, okay, there is nothing here. All you have is 2 points A and B. Okay, and then a wire. Okay, and the electrons are present here, which actually are even invisible to our naked eye. We can't see this, but in the diagram I have shown you. Okay, so now we want these electrons to move, and the electrons are negative charge carriers. Okay, me, I don't have any charge. I'm neither positive nor negative. Okay, but here the electrons are negative charge carriers. So how do we make this? Okay, how do we make these negative electrons move from this point to this point? Okay, in order to make the electrons move, I need energy. Okay, I need energy. So I need energy. I need energy. So let's bring energy. Now from where will I bring energy? I have to bring energy from external source. So I have to bring energy from external source. So from an external source, I have to bring energy. So what? Okay, what will be my source of energy? My source of energy will be a battery. All right, and you are familiar with the battery, now. A battery looks like this. Okay, this part is called plus, this is called minus. Isn't it? This is a battery. Okay, we are familiar with battery. We have remote batteries, we have alarm clock batteries, we have got wall clock batteries, then we have motorcycle batteries, we have vehicular car batteries, we have inverter batteries. Okay, there are big batteries also. So like that, we have different varieties of battery. We have even watch batteries also. Okay, the smallest cell. Okay, so this will be the source of energy. So the external source, this will be our source of energy. Okay, so what I do is I bring a battery and I connect the battery here. So let the battery be connected here. So this is my battery. Okay, now you all know that the battery has got two terminals. These are called terminals. Okay, these are called terminals. These are called terminals. The battery has got two terminals, positive terminal and negative terminal. So here, this is the positive terminal and this is the negative terminal. Yes or no? Okay, now this is the negative terminal. Okay, this is the negative terminal. See the negative terminal, negative charge. Okay, here this is electron is negative. Now you tell me. Now you think here. Okay, now think. Okay, think hard. What's gonna happen? This part, okay, this part carries a negative charge and the electrons are negative here. Negative, negative. What type of force will they experience? A negative charge with a negative charge. So negative charge, negative charge. What is the force existing between a negative charge and a negative charge? Negative charge, negative charge. Between two negative charges, what type of force is existing? A force of attraction or a force of repulsion? Yes, repulsion. So between these two negative charges, they will experience a force of repulsion. So this negative charge will repel this negative charge. Understood? So this negative charge will repel, okay, this negative charge. So what is happening? This electron is being repelled. So the electron will start moving away from this point. Okay, this point will not move. This point is fixed on the battery. It is fixed now. It is fixed. Okay, so who will move? The free electrons. Remember, the electrons are free. They are free mobile electrons. They can move. Okay, metals carry free electrons. They can give these electrons to non-metals. So that means they can detach itself. These electrons can detach themselves. So okay, this electron, okay, now will move from this position, it will move away. It will move away. Okay, so this electron will move away. Okay, and then if I were to show you, okay, if I were to show you, let me erase this for now. Okay, so this electron will move away, and the electron will go here. Okay, then it will continue journey. Then it will go here. It's continue journey. It will go here. Okay, it's continue journey. Okay, now as the electron reaches here or here, look at this terminal. This is the positive terminal. The electron moving forward is a negative electron. Now here, this is the positive terminal, this is a negative terminal. So now it's between a positive terminal and a negative terminal. What type of force exists between a positive terminal and a negative terminal? The force between a positive point and a negative point is that of attraction. So the positive, okay, the positive, okay, will attract, okay, the positive will attract. So it will be an attractive force. So it will be an attractive force. It will be a pull. Okay, so it will be a pull. So the force will be a pull. So this will be attracted to the negative. This negative electron will be attracted to the positive terminal. All right, understood? Yes, is not? Yes. So it will be attracted to the negative. The negative electron will be attracted to the positive terminal. So did the electron move? Is the electron moving? Yes. Electron moving means charge moving. Yes. So when the electron move, charge is moving. Electron moving means charge moving. Electron moving means charge is moving, is it not? Very important point. Electron moving means charge is moving. So the electron is moving. Okay, since the electron is moving, charge is moving. Okay, so if you connect a bulb in between, then this bulb, okay, this bulb will detect this electron which is moving, and when the bulb detects the electron which is moving, what will happen? The bulb will glow. The bulb will glow. So the bulb will now start glowing. Why? Because the bulb is detecting charge. Okay, the bulb is detecting charge. The bulb is actually detecting the negative electron moving. So the negative electron, okay, the negative electron moves all the way from this end to this end. So as the negative electron moves, it has to pass through the bulb. And when the negative electron passes through the bulb, so the negative electron will go here and it will travel here, then it will travel here, and in the meantime, okay, the bulb glows. Okay, then after him, the next electron will come again continuously. There is no gap. Okay, one after another, one after another, one after another. Okay, the negative electrons, because there are crores and crores of electrons, isn't there, free electrons here. So one after another, sequence wise. Okay, sequence wise, one after another, one after another, one after another, one after another. Okay, they are all moving ahead. They are all moving ahead. So one by one, all the negative electrons, okay, they are moving ahead, and then they are passing through the coil of the bulb, and then the coil will detect that this is charge moving through the coil. This is charge moving through the bulb, so the bulb will glow. The bulb will glow. The bulb will glow. As long as there are electrons moving this side. Okay, at one point, the last electron will have moved this side, and when the last electron will have moved this side, what happened? Will the bulb still glow? No, the bulb will not glow. Now the bulb will not glow. Why? Because no electron is moving from this end to this end. No electron is moving anymore because, okay, gone, electron finish. So now the bulb will not glow because no electron is moving. Okay, but as long as the electrons are moving, the bulb will keep glowing because it is still detecting charge. So as long as the bulb detects charge, as long as the bulb detects electrons moving, the bulb is glowing. Understood? Clear or not? Yes. Okay, so electron moving means charge is moving. All right, now, so yes, now see, so we are familiar with this. Okay, now see, now there is something called current, isn't it? We call it current. So current, okay, current. So current, so let me write here now. So current, we are familiar with current. So current. Now if I ask you what is the direction of current flow, then what is the direction of current flow? You all know the direction of current flow, isn't it? Current is considered to flow from positive terminal to negative terminal. So the direction of current flow is from positive to all the way to negative, isn't it? So current flows in this direction from A to B. Yes or no? The direction of current is assumed to be from positive terminal to negative terminal. That's how I studied. That's how you have studied. That's how everybody in the world has studied. Okay, because that is how it has been passed down from generation to generation. Okay, so the frontier scientists and all, they decided that it will be like this. So they have put it like that, because it was convenient. Okay, it was much easier explaining the people that, okay, see, by default we assume, okay, we assume this to be at higher potential and we assume this to be at lower potential. Okay, we assume plus to be at higher point and minus to be at higher point, minus to be at lower point. So flow will always take place from higher potential to lower potential. So by default, okay, people found it more convenient to accept that, okay, a flow will take place from plus to minus, okay, instead of from minus to plus. So people rejected this and people accepted this. Okay, so the public, the general public, found it more easier to accept this. Okay, so this was accepted. Okay, so this became more convenient for the public to understand than this, okay, from negative to positive. So by default, okay, by default, this became the convenient way of expressing current. So current, okay, current, which is a substance, which is an object, okay, whatever you call it. So current, okay, which is an object, which is a substance, or which is an entity, okay, travels, is assumed, okay, is assumed. So current is assumed to travel from positive terminal to negative terminal. It's already morning. You know at what time I'm recording this lecture? I'm recording this lecture at around almost 2:20 in the morning. Okay, I sleep late. Okay, I sleep late, and plus the reason why I record at night is because of the because there is less noise. Okay, and I'm a late sleeper, so I sleep late and then I wake up very late. Okay, school starts at 8:45. Sometimes I wake up at 8 also. Okay, sometimes I even wake up at 8:15, 8:20. So you know how I am. Okay, bad habit, but what to do now? I'm habituated to this, so I can't sleep early. And this class is being recorded at 2:15. Right now the time is 2:15, and the neighborhood, okay, this is the alarm. Okay, the neighborhood alarm. So the sun will emerge out very soon. So back to our discussion now. So current, okay, current is assumed to travel from positive terminal to negative terminal. So okay, conveniently, okay, current is that thing which travels from positive to negative terminal. But my dear students, okay, you know very well that nothing travels from plus to minus, isn't it? Is anything traveling from plus to minus? No, nothing is traveling from plus to minus. Remember that, okay? Nothing is traveling from plus to minus. If at all anything is traveling, it is the electron which is traveling from negative terminal to positive terminal. Agree? Yes. If at all anything is traveling, it is these negative electrons traveling all the way from this terminal to this terminal. Okay, wherein and in reality nothing is traveling from plus to minus. All right, so remember this. Okay, so if you want to know, okay, I think that is all right now. I don't need to explain more on that. Okay, so remember that. Okay, so this is called the conventional current. Okay, this is called the conventional current. So this is called the conventional current. This is called the conventional current. This is called the conventional current, or the conventional direction of current. Write down the conventional direction of current. Okay, direction of current. This is called the conventional direction of current. Whereas this one, the actual flow of electron, okay, which travel from negative to positive terminal, this is called the electronic. Okay, this is called the electronic current. So next one is called the electronic current. So electronic current. So electronic current, this is called, this is what is flowing. Okay, this is electronic current. What is electronic current? Charge flowing from negative to positive terminal. Right, electronic current is the charge which is flowing from negative terminal, which is this one, to positive terminal, Okay, this is called the electronic current. So in actual reality, electronic current is happening, but okay, for convenient purposes we study like this, that okay, there is something called current which move from positive terminal to negative terminal. I hope it's clear. Okay, this part is the part which is which may be confusing for you, but then I am also explaining. Okay, I'm also making sure that you understand very well what is happening in reality. Okay, what is happening in reality in actual practical. Okay, in actual practical, this is happening. In actual practical, every now and then this is happening. Okay, but for convenient purpose, for better understanding in the theory, okay, what we do is we follow this method. So we tell everybody, and we teachers, we tell you students that current flows from positive to negative. So what is that thing which flows from positive terminal to negative terminal? All the students will answer current. So should the teacher give correct, or should the teachers say is it the right answer or wrong answer? The teacher will say it's the right answer. Okay, but the same teacher should also teach you that, okay, in actual reality, nothing flows from positive to the negative. In actual reality, it's the electrons which move from this terminal, the negative terminal, all the way to the positive terminal. And this is called the electronic current. And current, which we call current, which is actually charge flow of charge. Okay, electric current, which is electric charge. Okay, it is because of this. Okay, the bulb is glowing because of this movement, because of the electron moving. The bulb is not glowing because of movement from here to here. When nothing is moving from here to here, how will the bulb glow? It's not. Nothing is moving from this end to this end. Nothing is moving from this point to this point. So the bulb will not detect anything. Okay. Whereas electrons are moving from this point to this point. So the bulb detects the movement of electron, and that's how the bulb glows. That's how the devices work. Okay, because they detect flow. They are detecting flow. Flow of what? Flow of electrons. I hope it is clear. Okay, should I move to the next point? All right, so let's move to the next point. Okay, so I hope you are following. So now you see. Okay, now remember. Okay, current flow, electron moving means charge is moving. Okay, now you see. Yes, so now remember yesterday's example where what happened was that I took a wire. Okay, and what I did, in 1 second we were looking at the current passing through, is not? So here 3 coulombs of charge were passing. In here I drew 6 coulomb of charge. Okay, 6 coulomb of charge. So now you see. How come? Okay, how come that 6 coulomb of charge was passing here, and how come that 3 coulombs of charge were passing here? Now these are charges, no? These are charge. So this charge, okay, they are being pushed. So remember here that the battery is giving a push. The battery provides a push. The battery is generating a force or a push. Remember here, push, force, energy. So this battery, okay, this terminal of the battery, okay, this terminal of the battery is providing a push to the electron. Now, if the push is strong, then will the electron not move faster? Yes or no? If the push is strong, what if this is a big negative charge? Let's make it big. Let's make it a big negative charge. Then this side also will become a big positive charge. What if this is a big negative charge and this is a big positive charge? Now you tell me, okay, this example, just tell me this example. You see this example. This is a big negative charge and this is the electron. Now you tell me between this and this, okay, these are also 2 like charges only, negative. So what they will do, there will be repulsion. Okay, there will be repulsion. But now this is between a big negative charge and a small negative charge. So what happened here? There will be repulsion, but then won't there be an increase in speed? Yes. Here this is a very big negative charge and this is a small negative charge. So here it will be very fast. Yes or no? It will be very fast. Whereas here it will be like this. It may be like this. Okay. They will push each other like this. But in this case, it may be like this also. It may be very fast like this. Yes or no? Okay. So like that. So if the negative charge here happens to be big, then the push will also be big. Understood? If the negative charge here happens to be big, then this push will also be very big. okay? And if the push is big, then what happens? In a given time, in a given 1 second, more electrons will pass through. Yes or no? Yes or no? Because here the electron, okay, will travel faster. So the first electron is gone, the second electron will also, okay, will be pushed with great force. So in that given 1 second, more electrons can pass or not? More charge will pass or not? Yes or no? Yes, isn't it? So, okay, so the push which the battery provides, okay, the push which the battery provides, okay, the push which the battery provides, if the push is great, then more charge will flow. More charge will flow means more current is flowing, nah? Okay, and if the push is weak, then less charge will flow. That means in a given time also, the charge flowing will be, okay, the charge flowing will be less in a given time. Understood? I hope this point is clear. Okay, now before I forget, now from where is the next question is, from where we have been, okay, we have been discussing a lot about the battery, and the battery is providing the external energy which generates the force, which generates the push. So all of these things are possible because of the battery. So the battery is a very useful component in understanding charge, okay? Now the question is, from where does the battery get the energy? From where does the battery get the energy? Very important question, because whatever we have discussed, okay, is all possible because of the battery. If I remove the battery, then what will happen? You will just have this one, and the electrons are here, not moving anywhere. There are lots of electrons here. There are lots of electrons, but these electrons are not going to move anywhere. These electrons are going to remain where they are. They are not going to move anywhere. Why? Because no source of energy. So if no source of energy, then the electrons are not moving. Yes or no? Yes. But because of having a battery, what happens? The electrons, they start moving. Charge starts moving. Okay. So we should also ask this question: from where does the battery, okay, get this energy? From where does the battery get energy? From where does the battery get its energy? Then the answer is, well, the battery is such a device that when the battery is being prepared, okay, chemicals are put inside the battery. The composition of the battery, if you study, okay, which you should study, okay, the composition of the battery is such that there are chemicals present inside the battery, and the battery uses this chemical energy. So chemical reaction takes place. The chemicals present inside there, okay, they undergo chemical reactions, and then the chemical reactions generate energy, and this energy is immediately converted into electrical energy, and this electrical energy is used to push the electrons. So let me write it here for you. So what happens is that, okay, the battery contains chemical energy. The chemical energy gets converted into, okay, electrical energy. Alright, chemical energy immediately gets converted into electrical energy, and this electrical energy is used to push electrons. Understood? So this electrical energy is used to push electrons. So the source of the energy is the chemical which is present inside the battery. And from where did the battery get these chemicals? While the battery is being made, the manufacturers have put it. The battery is such a device, okay, where there are chemicals, and the chemicals, they undergo chemical reaction which releases energy in the form of chemical energy, which is immediately converted to electrical energy, and this electrical energy is used by the electrons, okay, to move from this point to this point. So I hope things are clear. All right, okay. Now after all of this discussion, now I say you're ready. Now I say you're ready to face the, now I say you're ready to go and tackle the real topic, which is potential difference. Now you will understand what is potential difference. Okay, so now instead of writing this, what I will write our main topic, which is potential difference. So potential difference was our topic. So let us write the topic now. Potential difference was our topic. So everything difference. So this was our topic, isn't it? Potential difference. Now you are ready. Okay, so now let's talk about potential difference. And remember whatever has been discussed, okay? All of these things are important. I will not erase this now. So what is potential difference? So potential difference, the definition I'll give you: potential difference, okay, is the amount of work done, is the amount of work done in moving a charge from one point to another. So this is the definition of potential difference. Okay, my dear students, potential difference is the amount of work done in moving a charge from one point to another. Now this is very easy. Now let's try to understand word by word. Potential difference, okay, now remember, potential difference is also known as voltage. Okay, this is also known as voltage. This is also known as voltage. Okay, you must have heard the word voltage. Voltage is low, voltage is low. When the voltage is low, okay, things don't work properly. The fan is moving, but then the fan will not produce the wind because the voltage is low. So in low voltage, the fan is rotating, but you will not feel the breeze, the wind, because voltage is low, isn't it? Okay, so like that. So potential difference is the amount of work done in moving a charge from one point to another. Now let's go back to the figure here. So according to the definition, potential difference is the amount of work done. Now you tell me, who is doing the work here? Very good question. Who is doing work? Who is doing the work here? Who is doing the work in our discussion? Who is doing the work here? In the whole setup, who is doing the work here? Is it not the battery who is doing the work? Yes, it is the battery who is doing the work. I remove the battery. Okay, I've already shown earlier, if I remove the battery, what happened? Only the wire will be left with the free electrons. Okay, and the free electrons without any push, without any force, they will not move. So who is actually doing the work? The battery is doing the work. The battery is doing the work. Okay, the battery is doing the work. So potential difference is the amount of work done. Okay, who is doing the work? The battery is doing the work. Okay, to move a charge from one point to another. So in simple terms, potential difference simply refers to the amount of work done by the battery to move one unit charge, to move one electron. How much work did the battery do to move this electron, okay, from this point to this point? To push the electron from this point all the way to this point, how much energy did the battery lose? How much energy did the battery provide to push the electron from this point to this point? Okay, from this point to this point. That is called potential difference. Did you understand, my dear students? Okay, once again, potential difference is simply the amount of work done by this battery, okay, by the amount of work done by the battery to push the electron from this point all the way to this point. So in pushing the electron from this point to this point, okay, how much work did the battery do? How much energy did the battery lose? How much push did the battery provide to the electron? That is called potential difference. Simple, isn't it? Clear now? Okay, it's clear. So we can also write, that is, we can also write potential difference, V is equal to, not this stylish V, simple V, okay, voltage, V for voltage is equal to W, which is work done in moving the unit charge, small q. Okay, remember, my dear student, small q, remember this, it is voltage, which is amount of work done in moving a unit charge, small q. Okay, now so we can say voltage, okay, voltage is equal to work done by charge. We can also say like this. Okay, so voltage is equal to work done by charge, isn't it? These both are the same only. So the unit of voltage is volts. This is the unit of voltage. Okay, then the unit of work done is joules. Okay, then the unit of charge is, what is the unit of charge? Coulomb. Okay, coulomb or coulomb, is not? Okay, so now next, moving to the next point. Okay, next, now since you have understood, okay, till this much, the next set of discussion, okay, is going to be very important. Now if I say potential difference is 1 volt, what do I mean? Okay, if I say potential difference is 1 volt, what do I mean? So if potential difference is 1 volt, okay, if the voltage is 1 volt, okay, what do I mean? Now to answer this question, okay, to answer this question, remember this, okay, remember this, that at one time, okay, at one time, one charge is moved. Okay, that means, see, what I'm trying to tell you is this: there are many electrons here, but then the electrons, they are pushed one at a time. That means the first electron will get pushed, then the second, the third, the fourth, the fifth, like that. So if the electrons are heading in this direction, which means the first push was received by this electron, then it was received by this, then this, then this, then this. The electrons are headed in this direction. Okay, so who got the first push? This electron. Since it is in front, he got the first push, followed by this electron, second, third, fourth, like that. Okay, electrons, they don't move like this, they don't move in cluster. Okay, if you are thinking that electrons will move like this in cluster, in packets, like this, okay, and then push will be given like this, wrong. Electrons, they don't move like this. Electrons, they move turn by turn. Okay, so remember, this is not happening. This is how the electrons are moving. Okay, one at a time. So the first electron goes, second electron follows, third electron follows, like that. So as per the definition of potential difference here, potential difference is the amount of work done in moving a unit charge. Okay, though I have not written the word unit. Okay, a unit charge means one charge from one point to another. So when I say, if I say potential difference, okay, is 1 volt, that means, okay, charge move is one charge only. Okay, the charge move is one charge. So how much work is done, okay, in moving 1 coulomb of charge? Okay, it will be 1 joules. Okay, so if I say potential difference is 1 volt, that means 1 joule of work is done in moving 1 coulomb of charge. All right, once again I repeat, if I say, okay, if I say potential difference is 1 volt, if I say potential difference is 1 volt, now potential difference is what? Potential difference is the amount of energy which the battery provides to push the electron, is not, from one point to another point. So if I say that the potential difference is 1 volt, that means I am saying that, okay, 1 joule of work is done to move 1 coulomb of charge. Okay, then what if I say potential difference is 2 volt? Then remember, the charge will still be 1 coulomb only. Okay, the charge is still 1 coulomb only, because one electron at a time. Okay, and as per the definition, it's a unit charge, means one charge only. So if the potential difference is 2 volt, that means how much? What is it? This is 2 joules. If the potential difference is 2 volt, that means 2 joules of work is done in moving, okay, 1 coulomb of charge. Okay, then if I say potential difference is 220 volt, now this is the potential difference, okay, which is coming to our home. In India, the potential difference which the government of India provides to us, to our home, is 220 volt. So if I say potential difference is 220 volt, then how much work is done to move 1 coulomb of charge? So if you follow this, you know what is the answer. So what is the answer here? It's 220 joules. What is the meaning of this? What is the meaning of this? You have to understand this, my dear students. You have to understand this. If you don't understand this, then whatever we have discussed is useless. So you have to understand what is this. See, I'll tell you what is the meaning of this. See, 1 coulomb of charge. Now let's start from here. Okay, when I say potential difference is 1 volt, that means to move 1 coulomb of charge, 1 joules of work is done. So joule of, this is energy, isn't it? Energy. Okay, the energy. Work done is energy only. So to move 1 coulomb of charge, okay, so work done is 1 joule. Let's say this mild push, okay, this is called 1 joule. So this is 1 joule. Okay, to push 1 unit charge, I am doing 1 joule of work. This is 1 joule. Okay, that is called 1 volt. Then 2 volt, if I say potential difference is 2 volt, if I say potential difference is 2 volt, that means to move 1 unit charge, this is 1 unit charge, okay, 2 volts of energy is used. That means, okay, now the force is a little stronger. Okay, so compared to the previous one, this charge, 2 volt charge, will move faster, because in 1 volt, the energy which was applied on the unit charge was just 1 joule, isn't it? 1 joule to 1 tap only. Okay, I'm using one finger, 1 joule. Okay, then if it is 2 joule, the charge is still same, the marker is still same. Let this be the unit charge. So 2 joules now, so 2. Okay, then 3 joules, 3. Then 4 joules, 4, like that. Okay, then if it is 220 volts, if it is 220 volts, then in the same unit charge, how much energy I'm going to use? I'm going to use 220 joules. So basically, which means what? That means, so I'm kicking this one, isn't it? So I'm kicking this marker, I'm kicking this unit charge. So I'm going to kick this. Okay, so I'm going to kick this unit charge. So just now you tell me, the speed of the unit charge, will it be low or high? In this case, it's going to be super fast, isn't it? So the unit charge will travel very fast. Why? Because this charge is kicked with 220 joules of energy, or pushed. One single unit charge is being kicked or pushed with 220 joules of energy. Okay, that means the charge will move at great speed, isn't it? The charge will move at great speed. Are you following or not? See, once again, okay, if you have not followed for the last time, okay, you see, 1 volt means 1 coulomb of charge is pushed with 1 joules of energy. So this is 1 coulomb of charge. To push this, okay, we are using 1 joule because we are discussing 1 volt. So 1 volt means 1 joule of energy pushing this unit charge. 2 volt means to push this unit charge, 2 joules of energy is used. That means a little higher than the previous one. So 2 joules will be used, so more energy is used. Okay, likewise it keeps on increasing, and then we're discussing this one. Okay, and then we're discussing this one. 220 volt. 220 volts means what? The unit charge is same, because every time it will be 1 unit charge only, So 220 volt means this unit charge will be pushed with 220 joules. Just imagine the amount of energy which is used to push this unit charge. So what will happen to this unit charge? Will it travel slow or will it travel super fast? It will travel super fast. Why is it traveling super fast? Because the amount of energy used to push this is tremendous, isn't it? 220 joules of energy is being used. So here basically the strength is out of a kick, so it will go very fast. Yes or no? Okay, so 220 joules of energy is used, okay, to push 1 joules of energy, to push 1 coulomb of charge. And this is how charge is coming to our home. Okay, the charge coming through the socket, it is coming in this force. Okay, so 1 coulomb of charge, okay, is pushed with 220 joules, and this is the energy which is traveling to our home. We are using this to operate the fan, to operate the refrigerator, to operate all the electrical devices. Okay, so remember, previously also I told you the push, okay, the strength of the push is very important. If the push is strong, then the charge will travel faster. That means more current, okay, more charge, okay, in a given time. Since this is being pushed fast, this is pushed with great force, so in a given, once again, okay, the charge will travel faster. Okay, the charge will travel faster because it's being pushed with great force. Okay, in this case, in 1 second, since the push is a mild push only, okay, so in 1 second, I doubt 2 or 3 will pass through. But here, in 1 second, uncountable number of, okay, charge will pass through. Just an assumption. Okay, so here more current, okay, more charge here. Understood? So this is how it is. All right. So now I hope you all understood. Okay, so you have to remember this one. So let's define 1 volt. Okay, now let me erase this one and then we'll define 1 volt. This video may be a little lengthy, so let's define 1 volt. So what is 1 volt? Define 1 volt. 1 volt. So basing on what we have discussed just now, 1 volt, so potential difference is said to be 1 volt when 1 joules of work is done in moving 1 coulomb of charge from one point to another. Okay, so this is the definition of 1 volt. All right, now voltmeter is the instrument used to measure potential difference, also known as voltage. Okay, then certain things about the voltmeter which you have to know. So voltmeter is always connected in parallel. Remember, ammeter is connected in series and voltmeter is connected in parallel. They are opposite. Even the next point is also opposite to ammeter. Ammeter has zero resistance, voltmeter has extreme resistance. So voltmeter has high resistance. Resistance is ANC, I guess. Okay, so this is what you have to know about the voltmeter. All right, now let's discuss one question, okay, one numerical to test what we have understood. So this is a textbook from this is a question from the textbook. Okay, so the question is, how much energy is given to each coulomb of charge passing through 6-volt battery. So this is a question. This is a question from your textbook. Okay, it's a question from NCERT textbook only. So let's try to calculate this one. So what is given to us? So how much energy is given to each coulomb of charge passing through a 6-volt battery? So what is given to us? Charge is given to us. It's 1 coulomb, is not each coulomb means 1 coulomb. Okay, so Q is given to us. Okay, charge is given to us, and then passing through 6-volt battery. So V is given to us, which is 6 volt. So voltage is given to us. What are we supposed to find? How much energy? We are supposed to find energy. Energy means work done only. So using the formula, so the formula which we know is W is equal to, okay, no, the formula is V, potential difference is equal to W by C, isn't it? So potential difference is 6, W we are supposed to find, W is what we are supposed to find, and coulomb is how much? 1. So what you do, cross multiplication you do, so W will get 6 into 1, which is 6. So the answer is 6 joules. Alright, so it's not difficult, nah? The formula that you have to use is this one, okay? This formula you have to use. This is the formula for potential difference. See, it's this easy, okay, my dear students. Science numericals you dread and you are afraid, but it's not difficult once you understand the concept. Okay, it's not very difficult. All right, so this is an actual numerical from your textbook, so it is there in your science textbook. Okay, so I will end the video from here, but before I go, okay, to test what you have understood, so this is homework for you. Okay, in every video lesson I give a homework, okay, for you to practice, and it really makes me happy if you participate actively. So I encourage active participation. So please, my dear students, participate. Okay, that is how you can motivate me and encourage me, okay, to come more in front of you and put and make good videos for you. Okay, so boost me like that. So question, okay, if, okay, potential difference is 12 volt, okay, then this one, then give me the value of this one. Okay, what is the work done here? Find the, okay, work done. This is work done. Yes, this is work done, no? Yes, find the work done, or value of, this will be the value of W, na? Yes, okay, value of W. So what will be the value here? Your answer, give me the answer in the comment box. All right, so you have to find this, okay, find the value of W. Okay, find the value of W. This is W. Okay, so you have to find work done, okay, which is the value of W. You answer this in the comment box. So this is it, my dear students. Thank you for joining in and watching. Okay, the video must have been lengthy, but I believe that it was worth your time and then you have understood. So I'll see you again in the next video. Until then, take good care and God bless you all.